Hello there. In today's video, we'll be going over another Leet code problem. This one doesn't have as much of a trail of thought that we have to follow to reach the best solution, but rather than learning an approach, I'm hoping you'll learn some new methods and techniques. Before we get into it, I'd like to thank Jane for taking a look at my solution and even offering one of her own. Alright, without further ado, let's get started. Alright, so in today's problem, we're given a 32-bit signed integer, and we are told to reverse its digits. So as an example, if we're given 1, 2, 3, the output should be 3, 2, 1. Likewise, if we're given a negative number, like negative 1, 2, 3, the output should be negative 3, 2, 1. Okay? But before we move on to solving this problem, it's important to note that we're also given a constraint. We're dealing with an environment that can only store 32-bit signed integers. So, if we ever overflow, our system should output 0. Okay? Alright, now knowing this, try pausing this video and giving this problem a go. Spend a maximum of 20 minutes or so, and then come back. Okay? Alright, I will see you soon. Okay, so my first idea to solve this problem was to get our number and turn it into a vector. We'll do this by getting each individual digit of our number and turning it into one of the vector's elements. Okay, so for example, if we have 1, 2, 3, the corresponding vector would be 1, 2, 3. And this helps because now we can do some magic. We can get each number and multiply it by 10 to the power of its index. Okay, so for example, 1 times 10 to the power of its index 0 will have 1. Likewise, 2 times 10 to the power of its index 1 will have 20. Last one, 3 times 10 to the power of its index 2 is 300. Now if we sum all these three numbers, the magic that I mentioned happens. We have 3, 2, 1, which is the number reversed. Okay, so this is our plan of action. Now that we have one, let's get to coding it. As per requests, this time around we'll be using VS Code to code our solution, as it provides us with our good old compiler friend. And to get us going, I've already brought LeetCode's function signature into scope, and we can pass then our test cases from main. Alright, so for now, ignoring all edge cases, I'll quickly whip up the solution that we came up with during the discussion, and I'll talk about it when I'm done. And done. So to start off, we're getting x in a mutable variable and storing whether this initial x is negative or not. We're doing this because we have to take the absolute value of our test case because of how we're handling converting it into a vector. So what we're doing is we're converting it to a string first, and then we're getting each individual character digit into a collection, being this collection a vector of i32s. Okay, and then again, just like we mentioned in the discussion, we will be getting each item of the vector, multiplying by 10 to the power of its index, and then adding each result to the previous sum. Once this is done, we just restore the original sign and return it. So I have a couple of tests that I came up with that we can try out. Well, these ones are just the ones that were given to us, and this is a couple of edge cases. So for example, we have i32's maximum value, minimum value, and in here is a value that reversed is larger than our I32 max value. So it should fail when reversing, right? And we should get a 0. Okay. Now, before we actually test our solution, it's important to note that LeetCode runs our code with the release flag. So, considering that this is a problem that involves overflow, and overflow handling is a bit different in debugging than it is in release, let's do a cargo run release. Doing this, we see that our code worked for the 3 easy examples that were provided to us, but completely failed after it. Just look at it. When reversing a maximum positive value, we got a negative result, which screams overflow. And when attempting to reverse our maximum negative value, we panicked. So we're not really catching our overflows. And a way to remedy that is to perform checked operations. That is, instead of abs for absolute, we'll do a checked absolute. Instead of normal addition, we'll do a checked addition. And instead of a normal multiplication, we'll do checked multiplication. So let's just quickly apply these changes. Here we'll have, as mentioned, checked abs. In here we have to change it a bit. We'll set this to be equal, and we'll say test case reversed dot checked add, and we'll be adding onto all this, and this will become also a checked multiplication. Right, and one more parenthesis. Now the last one is in here. This will be checked multiplication as well. So checked, well, and there we go. Now the problem is, and VS Code is already sort of spoiling it, checked returns an option, checked operations. And to fix this, I would really like to use the question mark operator. But that means that we would have to change the function's signature. Or does it? Instead of changing it, we can instead create an inner function and clean things up a bit. So let me do just that. So first things first, we removed the mutable test case variable and just made x mutable in the inner function. Due to this, I renamed every test case variable to be x. So before we had test case vector, now we have x vector. Before we had test case reversed, now we have x reversed. Okay. Now moving on, as I mentioned, due to the change to checked, we added the question marks here, here, and here. Alright, now outside the inner function, we're just, well, calling the inner function and conveniently unwrapping to 0 whether things fail. Now running this, we will get and there it is, all the expected results. But for the sake of completion, let's actually copy our work and bring it onto, oops, that's not what I meant to do. That is not what I meant to do either. So let's copy our work and bring it into, or onto LeetCode to submit it and see our stats. Now upon submission, see that I was testing quite a bit, but upon submission we get that our runtime is of 0 milliseconds and our memory usage is of 2.1 megabytes. This means that we're doing better than 100% of Rust online submissions in terms of runtime, and 27% of Rust online submissions in terms of memory usage, which is pretty good if I say so myself. I mean, it isn't the best in memory usage, but Leet code isn't really super reliable in terms of memory usage when it comes to Rust. As an example, the same submission, all the same code, in a previous run yielded this. The solution was better than 86.69% of Rust submissions, and we had a 1.972 megabytes. Same solution. So, yeah, I don't know. Take that as you will. And that will be it for today. Thank you so much for watching, and I will see you next time.